Human babies are spectacularly bad at thinking. A newborn crow, within weeks of hatching, can already learn to recognize individual human faces and remember which ones threw rocks at the nest. A baby octopus emerges from its egg, already capable of hunting, problem-solving, and navigating complex environments entirely alone. A young border collie starts showing reasoning ability within months of birth. Meanwhile, a human baby will stare directly at a fan for 20 minutes as if it just invented the concept of spinning. Put a blanket over a toy, and a newborn acts like the toy has ceased to exist forever. Basic object permanence, the understanding that things continue to exist when you cannot see them, does not fully develop in humans until around 8 or 9 months. A creature that will one day compose symphonies, design spacecraft, and argue philosophy currently cannot figure out where the ball went when you hid it under a cup. From any objective standpoint, this looks less like the early stage of the smartest species on Earth and more like a profound malfunction. So why does it happen? Why does the animal that will eventually outthink every other creature on the planet start its existence barely capable of tracking a moving object? The answer is not a bug. It is the most sophisticated feature evolution has ever produced, and understanding it changes how you think about intelligence itself. Start with what is actually happening inside a newborn human brain, because the numbers are staggering. At birth, a human brain contains roughly 100 billion neurons. That is the same number an adult has. The hardware is all there. What is missing is almost everything else. Neurons connect to each other through synapses, and at birth, most of those connections do not exist yet. A newborn has roughly 2,500 synaptic connections per neuron. An adult has around 15,000. Between birth and age 2, the brain is adding synaptic connections at a rate of approximately 1 million per second. 1 million per second. That number is so large it barely registers as real, but it is what is actually happening inside the skull of a baby that appears to be doing nothing more useful than drooling at a ceiling fan. The brain a baby is born with is not a finished version with the training wheels still on. It is a skeleton that still needs most of its structure built. And unlike every other organ in the human body, the brain builds that structure primarily from experience, not from growth alone, from input, from what happens to the baby after it is born. Which means a newborn brain is not underpowered. It is waiting. It is the most sophisticated learning machine ever produced by evolution, sitting almost empty on purpose, ready to be shaped by whatever world it happens to find itself in. But why empty? Why not arrive with more pre-built capability, the way a foal arrives knowing how to stand, or a salmon arrives knowing how to navigate rivers it has never seen? The answer comes back to the same catastrophic evolutionary conflict that explains why human babies are born physically helpless. The brain that produces human intelligence is too large to finish developing inside the womb without killing the mother during delivery. Human gestation is effectively cut short by the limits of the birth canal. The brain that arrives at birth is therefore not an early-stage brain that simply needs time. It is a brain that was interrupted mid-construction and needs to finish building itself outside the body. Neuroscientists estimate that if human brain development continued inside the womb to the same developmental stage that other primates achieve at birth, human pregnancy would last approximately 18 to 21 months. At that gestational age, no human baby could be born alive. So evolution made a deal. Get the brain out early. Let the world finish building it, which sounds like a compromise. It turned out to be a masterstroke. Here is what that deal actually produces. Because the human brain builds most of its structure from environmental input rather than genetic pre-programming, it becomes shaped by wherever it happens to develop. A brain that builds its neural architecture from the patterns of a specific language wires itself for that language at a level of fluency no adult learner can ever fully replicate. A brain raised in a particular social environment wires itself for the subtle rules and hierarchies of that environment. A brain exposed to music early builds auditory processing structures that remain altered for life. This is neuroplasticity, operating at its maximum possible setting, and it only works because the brain arrives unfinished. A fully pre-built brain cannot be rewired by experience to the same depth. It is already done. The seeming stupidity of a newborn human is the exact mechanism that makes adult human intelligence possible. The empty cup fills to the shape of whatever pours into it. This also explains something that has puzzled researchers for decades. Human babies appear incompetent at almost every specific cognitive task you test them on. Object permanence, spatial reasoning, basic cause and effect. They fail consistently at tests that other young animals pass with ease. But they are extraordinarily good at one thing that no other animal comes close to matching: statistical pattern recognition across massive volumes of simultaneous input. A baby cannot tell you where the toy went when you hit it. But at the exact same moment it is failing that test, it is running complex statistical analyses on every speech sound in its environment, building a probabilistic model of its native language's structure, tracking the emotional valence of dozens of different facial expressions, learning the specific causal relationships between its own behaviors and the reactions of the caregivers around it, and cross-referencing all of that information against everything it has already logged since birth. It is not paying attention to the cup. It is doing something that makes the cup completely irrelevant. It is building the underlying architecture that will eventually make the cup trick trivially obvious. The apparent stupidity is not inattention. It is total concentration on a different level of the problem entirely. The baby is not slow. It is operating at a depth of processing that the cup game simply cannot measure. And then there is the timeline. Human children remain cognitively dependent far longer than any other primate. A chimpanzee reaches cognitive maturity in roughly half the time. A macaque in less than that. From a pure survival standpoint, spending a decade and a half feeding, protecting, and educating an organism that cannot yet fully contribute to its own survival sounds like an evolutionary disaster that should have been selected out millions of years ago. Every other species that stayed dependent that long went extinct. Humans went the opposite direction. The extended childhood that looks so catastrophically inefficient is actually a feature operating exactly as designed and producing exactly the outcomes that made the investment worthwhile. Every year of extended learning produces compounding cognitive returns. A brain that spends 15 years building flexible, generalizable cognitive structures before being asked to specialize can ultimately solve problems that a brain locked into early specialization never approaches. The inefficiency is the point. The slowness is the engine. Human children play for years, and play is not rest. Play is not even fun in the simple sense. Play is the brain running controlled experiments on reality. Every time a child drops something off a high chair tray and watches it fall, they are testing a hypothesis about gravity and cause and effect. Every game of pretend is a simulation of social scenarios and their outcomes. Every argument with another child about the rules of an invented game is a negotiation exercise that builds the same cognitive muscles later used in law, diplomacy, and business. Researchers studying play across species have found that the animals with the longest and most complex play periods consistently show the greatest problem-solving flexibility as adults. Human children push that correlation further than any other animal on Earth. The apparent purposelessness of childhood play is actually the most intensive and sustained cognitive workout any brain ever undergoes. And it only works because the brain is still unfinished enough to be permanently shaped by what it learns. Which brings us to the thing that should genuinely change how you see human intelligence. Scientists spent a long time assuming the sequence ran in a predictable direction. Humans became smart, and as a result, their children needed longer to develop. The data now suggests the causality runs the opposite way. The extended helplessness came first, and the extended helplessness is what produced the intelligence. Species with longer dependent childhoods consistently show greater cognitive flexibility as adults. The long, stupid beginning is not the price of intelligence. It is the mechanism that generates it. Every civilization humans have built, every language invented, every scientific discovery, every work of art, every system of law and mathematics and philosophy, all of it is the downstream product of a brain that arrived at birth not knowing where the toy went when you hid it under the cup. Not despite that emptiness, because of it. The most intelligent animal on Earth starts out looking like the least intelligent thing in any room it occupies. It cannot find the toy. It stares at the fan, And every second of that apparent emptiness is the whole plan working exactly as it should, quietly building something that has never existed anywhere else in the history of life on this planet.